Hi everyone, welcome back to the channel. Today we are going to go straight into Easa part 66, physics, mechanics, statics, questions. Let's dive straight into it. So question number 1 says a vessel has 25 ml of water which produces 10 kilopascal of pressure. If another 125 ml of water is added, what will be the pressure in the vessel? So with this kind of question, you have to use proportion. So the V1, which is volume 1 equals 25 ml. P1, which is the pressure 1, equals 10 kilopascal. Volume 2, V2. So if another 125 ml of water was added, so that's going to be 125 plus 25. 125 ml plus 25. That is going to give us 150 ml in total. So we are asked to find P2. So we're going to use the formula P1 over V1 equals P2 over V2. But we are looking for P2. So we're going to cross multiply. P2 will be equal to P1 divided by V1 times V2. That is going to give us P2 equals P1. We have 10 kilopascals. 10 kilopascal divided by V1, 25 ml times 150 ml. Okay, so when you cancel it out, you're gonna get 6 here. So therefore P2 equals 10 kilopascal times 6 ml. That is going to give you 60 kilopascal. Into question number 2. Mercury has a density of 13,600 kilogram per meter cube. If a column of mercury in a simple mercury glass barometer shows a height reading of 0.76 meters, the absolute pressure is. So you have the density rho, that is equals 13,600 kilogram per meter cube, and you've been given the height, which is the h, that is 0.76 meters. Right, so you know g to be 9.8 meters per second squared. You can approximate it to 10 meters per second squared. So pressure equals rho g times h. That is going to give you 13,600 kilogram per meter cube times 0.76 meters times 9.8 meters per second squared. This is going to give you the pressure. So when you multiply these figures, it's supposed to give you 101.39904 Newton per meter squared, which is 101.4 kilonewton per meter squared. That is it. Question number 3. What height of a column of water is equivalent to standard atmosphere? So we have the standard figures. These kind of questions are the reason to why you have to try as much as possible to memorize some facts and figures within the physics courses. Put them in memory. It's going to help you. It's going to go a long way to help you. So question number 3, that is 33 feet. Question number 4, the unit of Young modulus is the same as pressure. So if you have Young modulus, E equals stress over strain. Okay, so stress has an SI unit, strain has no SI unit. Yeah, and stress is the same as pressure. That is Newton per meter square. Question number 5. A mass of X is Y meters from the fulcrum of a beam on the left hand side of it, and another mass P is kilometers from the fulcrum of the right hand side of it. For the beam to be in equilibrium, then, so if you have a beam, sorry, it's not straight. Yeah, if you have a beam and you have a mass here of X, that is Y meters from the fulcrum. Let's consider this to be the fulcrum. Yeah, Y from here, and another mass of P hangs, let's say here, that is P, the distance of Q. So for this beam to be in equilibrium, the sum of clockwise moments equals anti-clockwise moments. So have X times Y should be equals to Q times P. That is the answer. Straight into question number 6. Given that under a certain load, the stress suffered by the component is 100 kilonewtons per meter squared, and the corresponding strain is 0.5 times 10 to the power minus 6, the value of Young modulus of elasticity is. So if you know the formula for Young modulus, which is stress over strain, in this question you've been given all the parameters. So we have the stress to be 100 kilonewton per meter squared. We've been given the strain, that is 0.5 times 10 minus 6. Young modulus of elasticity equals stress over strain. So 100 kilonewtons, that's 100 times 10 to the power 3, that's kilo newtons per meter squared, divided by 0.5 times 10 to the power minus 6. Right, so here we can cross divide certain values out. So 0.5 would divide 100, that would be 200. So moving forward, we're going to get 200 times 10 to the power 3. We will bring the 10 to the power minus 6 up. So when you bring figures like that up, the power becomes positive, times 10 to the power 6. So we are going to get 200 times 10 to the power 9 Newton per meter squared, which is 200 giganewtons per meter squared. Question number 7. 1 Pascal equals 1 Newton per meter squared. 1 Pascal, 1 Newton per meter squared. 8. If a vector forms a quadrate, meaning 90 degrees from the vector, from the reference vector, that is the answer. Question 9. Which one of these is a measure of atmospheric pressure at sea level? Which one of these is a measure of atmospheric pressure at sea level? That is 76 centimeters of mercury. Sometimes it will not will give you different figures. So usually we have 76 centimeters mercury. That is 76 centimeters of mercury, Hg. Some instances will give you inch mercury, which is 29.92 inch of mercury, or water, that is 10.33 meters of water, H2O, all equals 1 atm. Question 10. A force of 10 million newtons is expressed numerically. So we have 10 million newtons. A million is 6 zeros. So we have 10 times 10 raised to the power 10 to the power 6 newtons. 10 to the power 6 is mega newtons, so the answer is 10 mega newtons. The unit of Young modulus are that of pressure. Shear strain is option 1, the angle of deformation in radians, the modulus of elasticity. Option 3, extension of our original length. That is the answer. So if you know the strain formula, that is extension, that is change in length over original length. Yeah. (13) A scalar quantity has magnitude only. Scalar quantity. So if you have a scalar, magnitude only. And when a vector is given, its magnitude and direction. Number 14. The height of mercury required to give 1 bar is 1160 millimeters of mercury. 1 bar equals 760 millimeters of mercury. Question number 15. A man drags a box across a floor with a rope that is at an angle of 60 degrees to the floor. If the tension in the rope is 500 newtons, the horizontal component of the tension is So you have to resolve these forces. If you want to resolve this force to the horizontal, you use the cos. So the horizontal component, let's say x, equals force cos theta, that's the angle. X equals 500 cos 60. What is cos 60? Cos 60 is half. So therefore x equals 500 times 1/2. That will give you 250 newtons. So if you can memorize this, it could help you solve all the trig identity equations, or use the formulas to derive the values of whatever identity you are given. So let's say if you have cos 60 adjacent over hypotenuse. So in this situation, that would be 1 here and 2. So cos 60 equals 1/2. Cos 60 degrees equals 1/2. Alright, question 16 says a fork-ended tie rod exerts a pull of 1 kilonewtons on its connecting pin. The cross-sectional area of the pin is 500 millimeters squared. The shear stress will be, so you have the value for the force, which is force equals 1 kilonewtons. The area equals 500 millimeters squared, and stress equals force over area. So you have 1000 newtons, that's 1 kilonewtons, divided by 500 times 10 to the power minus 6 meter squared. We've converted 500 millimeters squared into meter squared. So you have 1000 newtons divided by 500 times 10 to the power minus 6. 500 could cancel 1000, that's 2. So you're going to get 2 over 10 to the power minus 6, which can be rewritten as 2 times 10 6 to the power 6. Newton per meter squared. And 10 to the power 6 is mega. So that will be 2 mega newton per meter squared. The center of gravity of an aircraft is adjusted by 2 weights, 10 kilogram and 5 kilogram, applied 4 meters and 2 meters respectively aft of the center of gravity. To what position must a 20 kilogram weight be added to balance the center of gravity? Right, so you have 10 kilogram, 5 kilogram with distance from the center of gravity 4 and 2 respectively, and 20 kilogram weight is added to balance the center of gravity. So the question is asking what distance should the 20 kilogram be placed. So we're going to find the moment of each weight. So we have 10 times 4, that is plus 5 times 2, that will be equal to 20x. Okay, so the clockwise moment equals anti-clockwise moment. So we have 40 here plus 10 equals 20x. X will be 50 divided by 20. That will give you 2.5 meters. What torque loading would you apply to a nut if the force of the force is 50 pounds exerted 2 feet from its axis. This straight away, 50 times 2, you're going to get 100 pounds feet. So it's 50 lbs. Okay, that's a distance, 2 feet. So force times distance, that is 50 lbs, pounds force times 2 feet, it's 100 pounds feet. Question number 19. The specific torque loading for a boat is 50 pounds each, but an extension of 2 inches is needed to reach the boat in addition to the 8 inches torque range. What will be the actual rating? To be able to solve this kind of question, there is a specific formula that we can use. So the formula equals the actual torque AT times length of the torque range divided by extension plus the length. That is going to give us, we need 50 lbs.ins times the length, which is 8 inches, all divided by the extension 2 inches plus the length 8. That is going to give us 400 divided by 10, which will give us 40 pounds each. Question number 20. A slag is a unit of mass. Sometimes it could ask you the value of a slag. So one slag equals approximately 14.6 kilogram. With regards to Newton's third law, if a mass of air moves in a rearward direction, there will be a forward reaction. 22. Two forces are added together to equal a known amount. Then, if it is replaced with third force of equal magnitude and direction, this is called the resultant force. 23. A vector quantity is a quantity which possesses magnitude and direction, or possesses sense, magnitude and direction. Question number 24. A steel bar 2 meters long has a cross-sectional area of 0.01 meters squared and stretches 2 millimeters from a pool of 10 kilonewtons. The modulus of elasticity of the steel is, we know the modulus of elasticity formula to be E equals stress over strain, and we know stress equals force over area. Now we've been given the force to be 10 kilonewtons and the area equals 0.01 meter squared. So therefore stress will be 10 kilonewtons, 10 times 10 raised to the power 3 newtons divided by 0.01 meter squared, which is going to give us 1 times 10 to the power 6 newtons per meter squared. That is the same as 1 megapascal. 1 megapascal. Now going to find the strain. Strain formula equals change in length over the original length. That equals 2 millimeters divided by 2 meters, which is going to give you 0.001. Now we need to calculate for the Young modulus. So E, which is stress over strain, that is 1 megapascal. 1 megapascal divided by 0.001. That is going to give you 1000 megapascal. Which is the same as 1 gigapascal. 1 gigapascal. Question number 25. A tank measuring 5 meters by 5 meters by 5 meters, that's the volume, is filled with fresh water. The force exerted on one side wall will be, so we know we know pressure equals force over area. So therefore our force equals pressure times the area. And now we know our pressure to be rho GH. That is the density of the water times acceleration due to gravity times height. Okay, so we know our density of water, H2O, equals 1000 kilogram per meter cube. We know our G, acceleration due to gravity, let's take it to be 10 meters per second squared. We know our height. Because of the height of the wall, we need to find the average height. That is going to be 5 divided by 2. That's going to be 2.5 meters. Therefore our our force is going to be the pressure times the area. So area, we know area to be 5 times 5. That will be 25 meter squared. So our force will be the pressure times the area. That will be 1000 kilogram per meter cube times 10 meters per second squared times 2.5 meters times 25 meters squared. So this represents the area, and that represents the average height of the wall or the mid-level, and that is the density of water, and that is G, acceleration due to gravity. That is the height. Okay, this is going to give us 625,000 newtons. That is 625 kilonewtons. The yield point of a material is the point at which permanent deformation takes place. Compressive modulus can be defined as compressive strain multiplied by compressive stress. No. Compressive stress divided by compressive strain. That is the right answer. (28) Two couples with magnitude F act against each other. The resultant will be 0. Which of the following has no unit? Strain has no unit. (30) When a twisting force is applied to a bolt, what stress is exerted onto the head of the bolt? That is torsion. So twisting force is torsion. 31. If an object in air is submerged in a liquid, its weight will remain the same. (32) The quadrate component of a vector is 90 degrees to the original. (33) A point at which the total force of a body acts is known as the center of gravity. Center of gravity. Question 34. If a load of 481 newtons is to be lifted 200 meters with lifting equipment capable of lifting 13 newtons per square millimeter of stress, what is the minimum cable cross-sectional area in square millimeters required? So we know stress. Equals force over area. Now area will be force divided by stress. So we have our force. Our force equals 481 newtons, and our stress equals 13 Newton per millimeter squared. Therefore, our area will be 481 newtons divided by 13 Newton per millimeter squared. Since the question required us to leave our answer in inch square millimeter, we're going to divide it straight away. There's no need for any conversion, so that will be equals 37 millimeter squared. Straight away. (35) A force of 10 newtons is placed 2 meters from a pivot point. What is the moment? So we know the formula for moment to be force times perpendicular distance. So we have our force to be 10 newtons. Now distance d equals 2 meters. So our moment will be 10 newtons times 2 meters. That will give us 20 Newton meters. (36) Hooke's original law relating to the stretching of materials is the relationship between load and extension. So we take the Hooke's law, because that is the extension, that is the force or load. The SI unit of force is the newtons. If 1500 psi hydraulic pressure is pumped into an accumulator with a pre-charged air pressure of 1000 psi, the gauge will still read 1500 psi, because the accumulator pressure gauge reads the hydraulic pressure only when it is above the charged pressure, so it will still read 1500 psi. Question number 39. Elasticity is defined as the tendency of material to return to its original size and shape after a deformation force has been removed. That is the answer. Question 40. Which one of these is an approximate measurement of atmospheric pressure at sea level? So that's 33 feet of water. If the mercury is replaced with water in a mercury barometer, then the level of water in the tube will be 76, above 76, below 76, equal to that of mercury. No, that will be above 76. A lever of length 105 centimeters is used with a fulcrum placed 15 centimeters from the end bearing the load. Its mechanical advantage is, so we have mechanical advantage MA, because effort arm over load arm. That is going to give us 90 centimeters over 15 centimeters. So mechanical advantage, therefore 6. A force perpendicular to a beam produces what type of stress? Shear stress. If you have a beam, let's say a log, there is a force F that will shear the beam, so it's shear stress. Or shear force. Right, question number 44. A tie rod of cross-sectional area 400 millimeters squared is subjected to a tensile load of 80 kilonewtons. The resultant stress in the rod will be, we know the stress formula, equals force over area. Now our force is 80 kilonewtons. 80 kilonewtons divided by our area 400 millimeter squared. The answer is going to give you 0.2 kilonewtons per millimeter squared. That is the answer. 45. The extension of a spring can be determined using Hooke's law. (46) An object floating in water displaces its weight of the water. Weight of the water. 47. A load of 600 newtons is suspended by a cable if the stress in the cable is said to be limited to 15 newton per millimeter squared. The minimum cross-sectional area of the cable must be, so we know our stress equals force or area. Okay, to find the area equals force over stress. And we know our force to be 600 newtons divided by stress 15 newton per millimeter squared. 600 divided by 15 is going to give you 40 millimeter squared. That is the answer. (48) A pressure of 100 psi acts on two jacks in a hydraulic system having a piston area 2 squared inch and 4 squared inch. Yeah, so we know our pressure P equals force over area. Okay, so our force F for the small area, that will be pressure times the area. That will be 100 psi. 100 psi times 2 square inch. That is going to give you 200 pounds. So our force for larger will be same pressure, 100 psi times 4 square inch. That will be 400 pounds. Yep. So the answer is the smaller jack will exert a force of 200 pounds and the larger a force of 400 pounds. The smaller jack will exert a force of 200 pounds and the larger force of 400 pounds. That is it. Question 49. Particles in a solid are closely bound with room for vibration. That is it. 50. Stress is given by force or area. That is force per unit area.